in this video, we'll be speaking more on circular motion. Now, in the first video, we treated on circular motion in terms of formulas relating to circular motion. Okay? Now, in this video, we're going to treat more on the analogy between circular motion and linear motion. Please take it. Okay? But before then, let me define what circular motion is. Let's take a note, please. Circular motion can be defined as a motion of an object or body. Circular motion can be defined as a motion of an object or body in a circle or circular path. The path is this. Circular motion can be defined as the motion of an object or body in a circular path. Okay? Now let's take an analogy between circular motion and linear motion before we solve an equation of circular motion. Okay? Please write analogy between linear and circular motion. Analogy between linear and circular motion. Okay? It's just the relationship between linear and circular motion. Now listen. Now whenever you know more about linear motion here, you can easily know more about circular motion. Okay? We want to take the one we know to the one we don't know. We all know what linear motion is. If I see displacement, we will use x to represent displacement. So from this relationship of this guy here, we can easily understand this guy here. Okay? Now let's get a chart here. If I have a chart here, now in terms of linear, we call it velocity, and we use v or u to represent this guy. But in terms of circular motion, please listen to me please. We call it angular velocity, and we use omega or omega naught to represent this. The next one here is acceleration. We use A or calculator A to represent acceleration. We use A or calculator A to represent acceleration. Okay? Now we don't call it acceleration here, we call it angular acceleration. Angular acceleration. And we use alpha to represent this guy. Please take note. The next thing here is mass. We use n to represent mass. But in terms of circular, we don't call it mass, we call it moment of inertia. Moment of inertia. And we use I to represent this guy. Now in terms of force, in linear, we said that force is said to be mass times acceleration. Please take note. But from the relationship between linear and circular, we can easily form our formula here. We don't call it force in terms of circular. Please take note. We call it torque. And we use the symbol tau to represent this guy. So let's, from the relationship here, what is mass in terms of circular? We use what? Moment of inertia, that is I. Okay? Now, what is acceleration in terms of circular is what? Alpha, that is this alpha here. Okay? The next one here is said to be kinetic energy, and we use half mv squared. Half mv squared. Now, this half here is said to be a constant here. Please take note. So this guy and this guy is a parameter, that is what? A quantity. So we always use I to represent mass. We use omega to represent what? Velocity, right? So this is going to be rotational or circular kinetic energy will be equal to class 1 over 2 of I omega squared. Let's look into the equation of circular motion. Before we look into the equation of circular motion here, let's first of all know the equation of linear motion. Okay? Now, for the equation of linear motion, we say that the first equation is said to be V is equal to U plus AT. Remember this, right? The next equation is said to be V squared is equal to U squared plus what? 2AX. Please take note of this. The next one is said to be X is equal to UT plus half AT squared. This is equation 3. The next one is said to be S is equal to V plus U over 2 or T. So from this equation now, we can now transform this to the equation of circular motion. Now what we take V as in terms of circular motion class, we take V as what? Omega. Please take it. So this will be transformed to omega is equal to, what do we take initial velocity as? That is omega naught. Please take note of this. So this is going to be omega naught plus, what do we take acceleration to be? Acceleration is said to be alpha. Please take note. So this will be alpha t. This is equation 1. Do the same thing here. This will be my omega squared is equal to omega squared naught plus 2 alpha theta. Our S here, that is displacement, angular displacement is what? Theta. So when you do that, you are going to get equation 2. So let's go back to equation 3 here. This will be theta is equal to omega naught of t plus 1 over 2. 1 over 2 is a constant. It can never be changed. Please take note. So this is going to be alpha t squared. This equation 3. Lastly for this will be theta will be equal to omega naught, omega plus omega naught over 2 all times t. This is equation 3. Okay, now the next thing we are going to consider here is when do we use the equation of motion and when do we use formulas relating to motion. Now, whenever we are given 3 or more parameters in terms of motion, we use equation of motion. Whenever we are given 3 or more parameters in terms of motion, we use equation of motion. But whenever we are given only 2 parameters, we use what? Formulas relating to motion. Okay? Now, let's take a question here. Example 1, please. Alright, let's solve example 1 here. Okay? Now we are given a disk of radius 10 cm is rotating about its axis from rest with a constant angular acceleration. We all know the symbol for angular acceleration, that is alpha, 10 rad per second squared. The unit for it is rad per second squared. Okay? At t equal to 5 seconds, the t there is time. What are A, the angular velocity of the disk, B, the tangential acceleration and centripetal acceleration. Okay? Now, in terms of solving equation in physics, what you just have to do here is to list out the parameters, you obey the condition and know what you are asked to calculate. Okay? Now let's list out the parameter there. Radius is given to us as 10 cm. Okay? Now the radius is given to us as 10 cm here. So convert this 10 cm to meter, because in physics we use SI units. This is going to be 0.1 meters. Right? Now what they given to us here, they said from rest class, there are some certain statements you have to understand in terms of motion. Remember this in terms of motion. Whenever an object is starting from rest, the initial velocity equal to 0. Please take note. Whenever an object stops, the final velocity is what? 0. Please take note. Whenever an object moves in a constant velocity, acceleration, that is acceleration will what? 0. Please take note. So velocity equal to 0. Please take note. Whenever an object stops, the final velocity is what? 0. Please take note. Whenever an object moves in a constant velocity, acceleration, that is acceleration will what? 0. Please take note. So this one is saying from rest. So it means that this object is starting from rest. That is our initial angular velocity of slash 0. Please take note. Okay, what again? Our acceleration is given to us here. That is angular acceleration. So our angular acceleration is denoted into what? Alpha. This is equal to 10 rad per second squared. Our t here is given to us at 5 seconds. Alright? Now what again here? We are asked to calculate angular velocity. In this picture, we are asked to calculate angular velocity. Now, if you look into this, these parameters are more than 2, alright? Now, whenever we are giving 3 or more parameters in terms of motion, we use what? Equation of motion. So, I'm going to use equation of motion and not what? Formulas relating to motion. So, what is the equation that is suitable to this particular parameters here? Let's check into this equation here. Our omega naught is given to us here. Alright? Now our alpha is given to us here. Our time is given to us here. And we are asked to find angular velocity, that is omega. We are asked to find omega here. That means this equation is suitable for this given what? Parameters. Okay? Now let's use this equation here to calculate angular velocity, to calculate tangential acceleration, and to calculate centripetal acceleration. Alright? Let's solve for this. We are using equation 1. Using equation 1, that is omega is equal to omega naught plus alpha t. So let's replace this to calculate our angular velocity here. Okay, now our angular velocity here is said to be, it's not given to us here, the final one here, that is omega is equal to what about omega naught is 0 plus what about alpha is what? 10, okay, times what about our time here is what? 5. So our answer here is said to be 50 rad per what? Seconds. Okay, now the unit of omega is said to be rad per seconds. But sometimes this omega is always confusing to some students. Now sometimes this omega can either the angular velocity, can either the angular frequency, depending on what you are relating it with. Okay, if you are relating omega with, please listen to me please. If you are relating omega with frequency, you call this omega angular frequency, just like in this equation here. Omega is equal to 2 pi f. At this point, I'm relating omega with what? Frequency. So I will call this omega what? Angular frequency. So if I relate this omega with velocity here, that will be equal to omega r. There's a formula like this, whereby I'm relating velocity with omega. I will call this omega what? Angular velocity. So if you look here, I'm relating this omega here with our velocity, that is our linear velocity here. So this omega will be called angular what? Velocity. So class, please pay more attention here. Okay, now we have calculated A. The next one here is B, tangential acceleration. Now in our last video, I proved the tangential acceleration. You can watch part 1 of circular motion. But the point here is, what is the formula for tangential acceleration? But pay much attention here. Tangential acceleration is not the same thing as linear acceleration. Okay, but in terms of velocity, linear velocity is the same as what? Tangential velocity. Okay. Now let's start to solve B. Alright, letter B, tangential acceleration. Okay, now we use our alpha to represent this for tangential here. We use A to represent this. Sorry for this. We equal to alpha of what? R. Okay. Now this is the formula for tangential acceleration. Okay, now let's replace this. Our alpha is already given to us in the equation as well, 10 rad per second squared. Our radius is what is last 0.1, right? We can now replace, am I correct? So this is going to be equal to plus, this is going to be 10 times 0.1. What is the answer? 1 rad per second squared. Okay, the unit of, 1 meter per second squared, because this is not angular, this is meter per second squared. Sorry for this. So we replace our alpha, it's already given to us in the equation. We replace our radius, the radius was given to us as mcm. We converted to meter, right? That is divided by what? 100. So when you do that, you replace into this formula here. What you just have to do is to know their formula and know what you are asked to solve. Okay, lastly for this, we are asked to find centripetal acceleration. Okay, now the question you have to ask here is, what is the formula for centripetal acceleration? Now let's write down the formula here and calculate the centripetal acceleration. Let's solve the last question here. The last question is said to be centripetal acceleration. So centripetal acceleration. Now the formula is said to be v squared over what? R. Okay, this is the formula here. In case you are finding the formula difficult, you can just go back to our part 1 for circular motion to get all the formulas relating to circular motion. Alright? Now if we look into this, velocity v is not given to us in this parameters here, that's the equation. Radius is given to us. We ask ourselves this question: where can we calculate velocity? V is not given to us. What is given to us is omega. Please take note of this. So where can we calculate this here? There is a relationship between angular velocity and what? Linear velocity. What is the formula here? That is V is equal to omega what? R. Please pay much attention to this formula. So our V will be equal to, what is our omega, please? Our omega is what? 50 times, what is our radius there? Please let us 0.11. How to get this? So let's time this. This time this gives us what? 5. So our V here will be equal to 5 meter per second. So it means that we are plotting our velocity here. Remember, listen, in this formula here, what was our bridge here is velocity. So if the velocity given to us, we can just replace here and find our what? Centripetal what? Acceleration. But if you look over here, it's not given to us, right? Now how do we find velocity here? If omega and radius is given to us, we use what? Linear velocity formula. So the linear speed or linear velocity formula is said to be V equal to what? Omega R. Now calculating velocity here, we have our velocity what? 5 meters per second, right? Now that means our velocity is not given to us here. This is not given to us. Radius is already given to us. Can we calculate acceleration at this point? Yes. So this will equal to plus 5 all squared over what? 0.1. So this will give us 25 over what? 0.1. So our centripetal acceleration here, that is AC, will be equal to AC. We are taking AC as centripetal acceleration. Please take note. Will be equal to plus. When you multiply here by 1, just want to calculate 25 divided by 0.1. This is going to give us 250 meter, 2 meter per second squared. Alright, let's take question 2 here. A disk starting from rest. Now, I told you guys when an object is starting from rest, that the initial velocity of that is what? 0, right? Okay. At t equal to 0 here. Now this t equal to 0 here means that the object is at rest. Rotate with a constant angular acceleration of 0.40 rad per second squared. Counterclockwise. Now this counterclockwise is in opposite direction. But listen. Whenever something is in opposite direction and the stuff slows down, it means that this opposite direction will be minus. Please take it. Whenever something is in counterclockwise, and the object slows down, it means that this will be minus. But whenever something is in counterclockwise, but it is speeding up, that is going more, at that point it is what? Positive. Please understand these two things here. So this stuff here is starting from rest and move. That means it's what? Moving forward. So it's not slowing down. You know what I get? Listen. If this is in counterclockwise and this object is slowing down, this counterclockwise will be like any parameter that is close to it to the negative direction. That's negative. But if definitely it moves forward without slowing down, it means that it is the same as what? Positive. Please take it. So that means since this object starts from rest and move again, this counterclockwise means that this is in what? This is that positive direction, right? So our omega here, our omega naught is equal to 0 here. Our alpha is equal to what? Please take note, 0.40 rad per second square. We have obeyed this man here. Why we say it? Because in terms of the counterclockwise, the object continues to move, right? Okay, so this is going to be positive. Okay, what again? What is the angular velocity at t equal to 30 seconds? They say what is the angular velocity at t equal to 30 seconds? So this is how we tackle some of the complex questions on physics. First of all, write down the given parameters. After then, obey the conditions necessary. Okay? Now we have obeyed the conditions here. We have written down the available parameters here. The next thing here is to understand if I'm going to use equation of motion or what? Formulas relating to motion. So we only use formulas relating to motion when the parameters are said to be 2. But if the parameters are said to be 3 or more, we use what? Equation of motion. Alright? Now class, this is more than 3 here. That is how we use equation of motion. How do we use equation of motion? We use equation of motion depending on the given parameters and the parameters we are asked to calculate. Now, what are the given parameters here? Omega naught is given to us here. Okay, let's check this. If this is valid, omega naught is given to us here. We are looking for omega here. Alpha is given to us here. T is given to us there. That means equation 1 is obviously valid, right? We can now use what? Equation 1. But if definitely we are looking for theta here and omega naught, omega is given to us, this is given to us, this is given to us, sometimes what? We can now use the word equation 2. So using equation 1, alright, using equation 1, now this is our equation 1 here, that is omega is equal to omega naught plus alpha t, alright? Now let's replace this one after the other here. Omega is not given to us here. This will omega equal to omega naught is 0 here plus. What is our alpha here? 0.4. 0.4 is the same as 0.40. Please take note. Times what? 30. So everything will be omega will equal to class. Everything will be 12 in what? Rad per seconds. Okay, the answer here is said to be 12 seconds. Okay. Now sometimes they will give you a question whereby you might use this or you might use this. Just know the given parameters and what you are asked to calculate. You'll be able to solve this here. Alright? Now what you just have to do here is to subscribe to the channel and get some of the advanced questions on this. And also you have to just share and like. Thank you so much.
No dey tire Jesus, mercy, mercy, no dey tire Jesus. He don do one before, he still dey do one again.